We're now going to take a look at piecewise functions, and we're going to start with a very simple piecewise function. So this is just a function whose ordered pairs are determined by multiple formulas. Okay, so this is how it works. I've started with a very simple piecewise function, and basically what it says is f of x is equal to one of two values. It's equal to -2 for all x that are less than 1, and it's equal to a +3 for all x that are greater than or equal to 1. And so let me graph this, and then we're going to define the domain and the range. So I'll just do like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So basically, here's 1 here, right? This is where the behavior of my function changes. So for all of these values in the domain, for all the values that are strictly less than 1, the value of the function is going to be a -2. So -2 is right here. So I'm going to have, it's going to go all the way over to 1. And then what I'm going to do here is I'm going to put an open circle, because at 1, it's not equal to -2. Okay? It's going to be equal to 3, because it's 3 for all x greater than or equal to 1. Okay? So from 1 on up, for this half, the graph of our function is going to be 3. And so now I'm going to put a dark circle, and then it's going to be like that. Okay? This is actually sometimes called the diving board function, because it kind of looks like a diving board here going into the water. So it's a very simple function. So what this is saying, this here is determining the domain. And it's basically saying for this particular part of the domain, over this interval, this is what you're going to use for the graph, or to generate the ordered pairs. For this part of the interval, you're going to use this, whatever this is. And so this is our function. So notice the domain here is going to be -infinity to infinity. Okay? The range here is basically just two numbers. Okay? It's not going to be like -2 to 3, because it doesn't take on values. It doesn't take on y values in between these. So there's really only two values. It's either going to be -2 or 3. So in this case, the range is not even an interval. It's just two values, -2 and 3. Okay? Now, the domain's going to be determined by this. Notice if this was strictly less than, but this was strictly greater than, then this would have been an open circle, and the domain wouldn't have been all real numbers. So let me give you an example of that. So this is the exact same function, except I don't have the line underneath the greater than sign here. And so basically, just to speed things up, here's 1, and here's -2, here's 3. And so basically, for everything less than 1, it's going to be -2, and this is an open circle because at 1 it's not equal to -2. But now this is also an open circle, right? And so it'll be 3 for everything strictly greater than 1. But at 1, it's not equal to 3. Okay, this circle is not filled in. Okay, so these are both open circles. And then if I were to state my domain, then this would be -infinity all the way up to 1, but this would be a curved bracket because it doesn't include the 1. And then I'm going to union that with 1 all the way up to +infinity. Okay, so this is basically saying all real numbers except for 1 there. you're going to leave the 1 out. Okay, because nothing at 1, it's not defined. Okay, and then the range here doesn't change. The range is still just those two numbers, -2 and 3. Okay, and another thing that I wanted to say is this. If I had a line under here and a line under here so that both of these were filled in, can you see a problem with this? If both of those are filled in, this would no longer be a function, because you would have an ordered pair that says 1, -2 right down here. You would have another ordered pair that says 1 and 3. Okay, these would be two. There'd be an infinite number of ordered pairs in our function, but both of these ordered pairs would be in there, and this would be two ordered pairs with the same first element and a different second element, and that's not a function. Another way to look at it is, if you look at this graph, there is a vertical line here that intersects the graph at more than one place, and that means it's not a function. Okay, so these are not by the way, these are not intervals like this. These are ordered pairs that are in the function. Okay, with infinite number of ordered pairs. Okay, so this graph actually fails to pass the vertical line test, but only at that one point. But that would mean it's not a function. Okay, you would have to take out one of those greater than or equal to, or less than or equal to, greater than or equal to, and make it strictly in order for it to be a function. Okay? Now, here's one that's a little more interesting. So basically, at 2, or for x less than or equal to 2, this graph is going to determine the y values of our function. But for x strictly greater than 2, this graph will determine the y values. So let's actually see if we can graph this. I see I'm going to have to go up to 8. And then this is 5. Okay, so basically here at 2, this is when the behavior of the function changes. It's splitting it up into these two halves. And so for everything less than or equal to 2, this is going to be the graph of the function. And this is a linear graph, and it starts at -3, and it has a slope of 2. So it's going to go up 2 for every one I go over. And then it'll go up 2, again, for every one I go over. And so this is actually at 2, and that's an open circle. And then this is the line here. So it's a line like that. And it has an open circle right here. And you can see there at 2, if I plug 2 in, I'm going to use this graph, and plugging in 2 gives me 4 minus 3, it gives me 1. So this is, that open circle is the ordered pair 2, 1. Oh, but by the way, this is not an open circle because it actually includes, I think I was thinking the other function here. So this is actually a closed circle, and then for this one it's going to be an open circle. Okay, so here what I'm going to do is, for everything greater than 2, this is going to be the function, right? So I have a Y-intercept here at 8, and then it looks like I'm going to go down 5 for every 2 I go over. 1, 2, 3, 4, 5, and then go over 2. And this is actually going to be the first point on the graph, because that's going to be where it starts at 2. But that's an open circle. Okay, so 1, 2, 3, 4, 5, and then over 2. So there's another point on my graph. And then I could go down 5 over 2, but this is enough. And I'm not going to draw the whole graph. You don't draw the whole line. You just start here, and then you go on like this. So this is actually going to look like this. So here at 2, okay, the behavior of the graph changes. For this, everything less than or equal to 2, you get the graph for y equals 2x minus 3. For everything strictly greater than 2, you get the graph of negative 5 halves x plus 8. Okay, this is a dark circle, and that's a light, an open circle. Okay, so now let's determine the domain and range. So the domain of this function here is going to be all real numbers again. Negative infinity to infinity. Okay, it's going to include the whole number line. Now, if I left that out so that this was an open circle, then I would have to leave out 2 here. Okay, and so it would be negative infinity to 2, curly bracket, union 2, up to infinity with the curly bracket. Okay, but otherwise in this function it's all real numbers. And then notice the range here. Okay, well, you get all y values here that are less than, this is 1 here. So you get all those y values, but then also here at 3, it doesn't include the 3, but it includes these values from 2 to 3. So basically, anything below 3 is included in the range. Okay, you'll have y coordinates that for any number below 3. Okay, and so basically, this is going to be negative infinity, and then it's going to go up to 3, but 3 is going to have a curly bracket there. Okay, because it doesn't include the 3. Now, if I switch these two around so it includes the 3, it would be a square bracket there. Okay, so let me do one more, but in this case, what I have here is I have a graph, and I want to write out the function here, the piecewise function. Okay, so you got to know about your linear graphs here, right? You got to know how, and so this will be a good review of linear graphs. So this here, the line here, so let me get some points here. So this is, I think, so I think I went down to, or I need to know what points these are. So let's just make some points here. So this is 4, negative 5, 4. There you go. Negative 5, 4 is what this point was supposed to be. And it'll be more clear on your graph. So this point here looks like that was negative 3, 2. So this point is negative 3, 2. Okay, this point over here is 3. 2. And then this point over here looks like this is 5, 0. And then this point over here, it looks like that point is 3, 1. Okay, so what I need is I need to find the line that goes through these 2 points. So I'm going to find the slope of the line, of this line, and we're going to use that slope formula. It's the difference in the y values, so 4 minus 2, over the difference in the x values, negative 5 minus negative 3. Okay, and so this is 2 over, this will be negative 5 plus 3. So that's negative 2. And so it looks like I have just a slope of a negative 1. Okay? And so you have like y equals mx plus b. So what I'm going to do is I'm going to write y is equal to negative 1x, right? Negative x plus b. And then to find the y-intercept, I can pick either of these points. So I'll pick negative 5, 4. So this would be 4 is equal to, and then I'm going to plug in the negative 5 plus b. And so then I get 4 is equal to 5 plus b. And so it looks like my b is equal to negative 1. Okay? And so my line here is y equals negative x minus 1. So that's what this would be here. This line would be, if you extended it out, have a y-intercept of negative 1, a slope of negative 1. Okay? And that's what you're going to use to define the graph here. Up to, it looks like that's negative 3. So what I can write here is we're going to have negative x minus 1 for x values that are strictly, that are strictly less than negative 3. Strictly less than, okay, because that's an open circle. Okay, so that takes care of this part. Now notice here we have a constant function, and the number is 2. So I have 2 for x's that are between, it looks like this is negative 3 to positive 3, right? So I got negative 3 to positive 3. And notice it doesn't include this again, but it does include that endpoint. So this is less than or equal to, that's strictly less than. And so that'll take care of this portion of the graph. Now for this portion of the graph, I got to find the line that goes through those 2 points. So again, using the slope formula for a line, the difference in the y values here, this would be 1 minus 0. And then I got 3 minus negative 5. 3 minus 5 for the difference in the x's. And this looks like it's 1 over negative 2. So it looks like my slope is negative 1/2. So then I get y is equal to negative 1/2 x plus b. And then what I'll do is maybe I'll put in this one here, where I get 0 for my y is equal to negative 1/2 times 5 plus b. Okay, so this will be equal to negative 5/2 plus b, and so my b is just equal to 5/2. Okay, so then my line, this line here, this is my slope, this is my y-intercept. So it'd be like negative 1/2 x plus 5/2. And this is going to be for x's, not including 3 here, okay, but everything greater than 3. So this is going to be for x strictly greater than 3. Okay, and so this is my piecewise function for this graph. And so I had to use what I know about linear equations to find the equations of these pieces, and then these are kind of what determines these domains here. So now let's find the domain of the whole function. Notice it's going to be defined everywhere except at that point, at that negative 3. And you know what? Actually, if I take these as endpoints, as I have here, it's not going to be defined below negative 5 or above a positive 5. So what this would actually be for the domain, it would include, because these are closed, it would include the 5, and then it would go up to 3, but it would be a curly bracket, and then it would start with 3, but it would be a curly bracket, and then it goes up to positive 3. Oops, but you know what? Let me just complete this. And then this would be a curly bracket 3 up to 5. And basically, I was following this, but I could simplify this here. 5, 3, and this would be a curly bracket union 3 up to 5. And this should be a square bracket here, sorry. So basically those two really collapse down into that. Okay, so this is my domain. And then what about the range here? Well, it looks like I'm defined for all these points, and even though that's open there, it doesn't matter because it's defined to be 3 for all of those points. And then this is an open bracket, right? So it's not defined to be 1 there, but as you go down from 1 here, it's defined all the way to 0. So this is how you would put that together. it looks like this doesn't get any smaller than 0, but it does include 0, so it's a square bracket. And then it's going to go up to 1, but it doesn't include the 1, and then it makes this jump. There's no y values in this part, okay? But then it's going to include 3, of course. It's 3 all along here, and everything up to 4 here. I think I said 5 earlier. I meant up to 4. And it does include that 4. So you would actually get this for your range. Okay? So, again, these are piecewise functions. They're very interesting. A lot of real-world problems as a process goes on. You know, what determines values might change from point to point in the process. And so you get this piecewise function. And of course you can do this with more than just linear equations, but at this point in the textbook, the piecewise functions they give you all are dealing with linear equations.